Last time we created some objects based upon game development and so forth. Um, this chapter 10, focuses very specific on a couple of objects that um, maybe is used to create shapes, graphics perhaps. The two types of objects are point and rectangular. If we get to the end of the chapter, we will. I think we'll get to the end. Um, Java AWT package provides a class name point intended to represent the coordinates of a location in Cartesian plane. So if you've had any kind of algebra, that's your x and your y. In order to use it, you have to import it. So let me go to NetBeans and I'll create a new project. Java with Maven, Java application. And I call this object example. I don't know if we're going after. I'll call it 2 just in case. And click finish. Under our source packages here, I want to create a new Java file. So I do a right click on it, choose new, choose Java class. And I'll just call it the class. It says we'll have a mixture of point and rectangular. Then click finish. Come over here, I'm going to steal some code. Copy. And paste. Okay, so we got our standard public static void main, so forth. The import goes at top. And you see it's java.awt point. Import java.awt dot it's uppercase. Yeah, uppercase. I don't know why my code completion isn't coming up on those, but that brings in the code that goes along with the point. In theory, if I right click on it and choose show Java doc, that'll bring up information on it. But since it isn't coming up with the code completion, it says cannot perform Java doc, and perhaps they didn't even create one for that. You have to create the help that comes up with that. Then to create a new point, you have to use a new operator. So you name it point blank. So down here, I say point, and then what do you want to call it? P1. Then you say P1 is equal to new point. Now, this is creates an instance, and the constructor is set up this way, but you can have different ways you can pass in parameters on that. Now you see they give the example here where you do 3, 4. I really don't know what this defaults to, probably 0, 0 if you don't put anything in. System dot console dot print line p1 dot get x. And I'm probably mixing this up with a different language. Go cheat. Out. Thanks. Console is C#. Except for it's console.writeLine. This is console, or this is out.println. Okay, so then I do another system.out.println p1.get y. Then we'll go ahead and run that. Go ahead and select the main class there. And see defaults to 0, 0. Yes. Yeah. Because you could have 1.1, 1, comma, 1.3. So instead of doing it that way, I can pass in parameters. Unfortunately, it doesn't pop up. When it pops up, it shows you all the different ways you could put in parameters. Maybe there's even a third way. And now if I run this, you see it's 3 and 4. Now this is kind of standard, using gets and puts to set it. Probably, if I look, there's p1 dot put. Set x. Let's see, instead of guessing. Set location. That's kind of bad. They don't put any sets in there, yeah, set is a. Oh well. Sometimes you hide it so you can't access the variables directly. So you control it with gets and sets. For example, remember our monster over here, and we made these public, so we could access them directly from the code. And over here, I did m1.name, so I could access it directly and set it equal to Godzilla. Another way of doing that is instead of making it public, you make these attributes, these variables, private. And then they cannot access them directly. See how the little red squiggly appears? Because you can't access it. And you want to control how it's set. So what you do is that's name. So you have down here, you have a public set name. And then you pass in a string s. And this doesn't do anything more exciting than, well, it can, but to set that. And I'm forgetting something, void. So I'm not returning anything. So now if I want to set the name, I have to actually call this this method. What goes along with that is a get. And this would be a public string get name. And this would return this dot name. Now I know it seems kind of haywire. Why do you do this set and get like this? But it's just as easy to make it public and access it directly. Good object-oriented design implies you use gets and sets. Because then you can control. You could have 100 lines of code in here to make sure they did it right. For example, is there a maximum on what a string can be? Well, if there is, then I need to check it, don't I? Especially if my database only allows 20 characters and they put in 50, then they're going to be surprised. So here you'd have your code to check that. So then over here, when we want to set that name, we would say one.set name, and we pass in Godzilla. If I wanted to retrieve, well, here's another one. m2.setName Dracula. That'll get rid of that. If I want to retrieve the name, you see over here, it's got a little red squiggly when I retrieve it. To retrieve it, I just do a get name. And same down here. So that's the idea of the get and set. Let's see. Does that make sense on the concept behind gets and sets? And like I say, they got a get that retrieves it, but I don't see a set, so that's kind of unusual. They do got a set location, I think, right here. And the implication is when I read it, it sets the location of the point. They also have a set location down here that changes the x and y. So this is how they use. They don't have an individual set for each x and y. They just have a set location. Now notice these names are all the same, aren't they? Set location, set location, set location. This is called overloading. And what the idea is there is you pass in different parameters and it recognizes based upon what parameters you pass in. You're asking, is it an integer? Is it a double? The answer is really yes, both. Because you see they got an overload here. Set location for integer x, integer y, double x, double y. When you pass in integers, what it does is it calls this one. When you pass in double, it calls this one. When you pass in a point, it calls this one. And we'll talk more about overloading. Let's see. Talk about new, that creates an instance. The variables that I've been referring to, I've also called them attributes. Because when they're part of an object, they're called attributes. But you'll see some books will refer to them as variables, some languages will. This one I forgot. I also refer to them as fields. And use dot notation, just like we've been seeing. And then down here, just print out those. That's kind of bad. That looks like you can access X and Y directly. Let's see if that's true. P1 dot X right now. Can you set it? Yeah, no errors. So how's the variable, the attribute X declared? Public. So that's declared as public. Why you would have a get X on a public variable, I don't know. The idea of a getX is that you don't access the variable directly. Anyway, I suspect that's a leftover from way back when, because they know how to do objects correct. I'm drawing a blank on what AWT stands for. Abstract Window Toolkit. Now I put old in there. Here it talks about it in Wikipedia. Is Java's original platform-dependent windowing, graphics, and user interface widget toolkit. The new one is Swing. So AWT is old. That's what I say originally, because they probably just never updated it. Because when you do a lot of this, you use Swing, you don't use AWT. You notice over here, we got swing controls, and this is where we've been spending most of our time. There's also AWT. Label, checkbox, scroll pane, scroll bar. Might be the equivalent, I don't know. So you got different items here. And again, this is the old style of doing it. This doesn't mean it's still not used, but you see a lot of these are swing menus, swing windows, and so forth. Objects as return types, you can import a rectangle. AWT rectangle. By doing that, you'll have access to all the rectangle items. Now let's not do that. Let's kind of go off on a tangent. It's still going to follow the book, but we're going to do it differently. I'll get these imports here. I'll get rid of them. And which code am I in? Object example. No, object example 2. Down here. So under my object example, I'm going to right click, choose new, and I'll choose Java class, and I'll call it rectangle. And click finish. So then down here, private double width and private double length. That's what a rectangle has, right? It has width and length. Is there anything else a rectangle has? No. I suppose you could say it has position if it's placed on a rectangular coordinate system. And we could add that in after later, but that's all we have. So now if I go back to the class here, and I'm going to get rid of some of these, kind of clean them up. I'm going to declare a rectangle. So rectangle R1. See if I can spell. Okay. Now I do R1 equals new rectangle. So this declares it. This creates a new instance of it. So whenever you see the new, although there's some programming languages that you don't have to put the new, it's implied. C# is big about that. You use objects in a lot of places where you don't put the new. But if you see the new, then that typically refers to an instance. Now, at this point, I don't know. I have no clue what length and width are equal to. Probably null, if I had to guess. If I go back to my rectangle over here, I can put down here a public rectangle. Might have put a static in there. I don't know. There we go. And I'll say width is equal to 0, and length is equal to 0. Now, I could refer to this as this dot width and this dot length. There's be nothing wrong with that. This is a constructor. This is what I use to construct an instance of my object. Now, these are private, so I can't access them directly. So I need a get and set for each one of those. So I do a public void set width, and I'll pass in a double called width. And then I'll say this dot width. This refers to whatever instance I'm working with is equal to width. The width here after the this refers to my attributes up here, my variables associated with my class. This width here is a parameter I'm passing in. Some people like to have those the same name, some don't. That's entirely up to you. I haven't read anything that says you have to do it, this way or that way. In terms of functionality, you get some authors say you should. Public void, and I need to set height. Let's say double height. And I'll say this dot height is equal to height. And height, where did I get that at? Set length. Try that again. Now, sets always are void because you're just setting the value, you're not returning anything. Your gets always need to have a get type associated with them. So if I do a public double get width, then this is going to do nothing but return the width. And if I do a public double get length, this is going to do nothing but return the length. Does that make sense on gets and sets? Now that's the proper way. I'm sloppy in my programming. I like to make them public. It's so much easier just to access them directly, but I know that's not proper design. Proper design is you control exactly the interface into it, just like you control the interface into a remote. You wouldn't want people opening it up and trying to turn it on by manipulating the circuitry. Okay, so now over here, when I create my new rectangle, I'm guessing, well, I'm not really guessing at this point, but it should print R1 dot get length. It should be printing 0. System.out.println R1.get width. And you see it pop up, they have them there. Now notice it says Java doc not found. I don't know if I know how to do the Java doc. I might Google it here in a second just to show you what in the world, how you do that. And then I run that. It should print 0, 0. It does. See how we got 0, 0 here? I can set these. If I want to set the width, the length, I do R1.set length, and I'll pass in length is going to be 10. And R1.set width, and I'll make that 5. So then my area is going to be 10 times 5 or 50. The rectangle? I thought it'd be more meaningful if we create our own rectangle instead of just using a predefined one. Now, if you think about what else might go along with a rectangle, well, I can calculate the perimeter. So I'd be returning something because you don't want to necessarily have any kind of print inside of your object. Your object should return something and then you print it. Again, you'll see me do that sloppy, but that's the way it should be. So instead of you don't usually use get. Get and set is really reserved specifically for those class variables, those attributes. So I might say calculate width area, and I'm going to have a public double calculate perimeter. Okay. Now, I'm not passing anything in here because since it's actually a method contained in that object, that instance, it already has access to the length and width. So here all I have to do is return, and I'm going to talk about a different way you can do this, but return this dot width times this dot length. So it's going to retrieve whatever the width and length is, multiply them together, and return that to wherever this was called from. This one, I'm going to return 2 times the width plus 2 times the length. So that's our formula, 2W plus 2L from geometry. So now over here, I could say system.out.printf. The area is %.2f slash n, comma, and then I'll say R1 dot calculate area. And system.out.printf, the perimeter is %.2f slash n, R1 dot calculate perimeter. I'm pretty wordy there. It's like almost a sentence just for my name and my method. But is there any question on what it does? No. So sometimes it's better to be wordy and it self-documents itself. You know exactly what it's doing. It's calculating a perimeter. Well, what's this one doing? Well, it's calculating an area. It just makes your code so much easier to read if you use variable names that are meaningful. Okay, so now if I run that, Let me see. 10 times 5 is 50. 10, 20, 25, 30. Okay, so all that's correct based on numbers I input. See, could I do anything else with the rectangle? Probably not. But this is creating an instance. Well, what if I wanted to pass in the length and width to begin with? If I come over to my rectangle here, and I think it can be anywhere, but I'll put it up with the other constructor. Here's my constructor. Here I'm going to say public rectangle and double length, comma, double width. I think it's comma, not a semicolon. May seem weird. It's called the same name, isn't it? It's just got different parameters. This is another constructor. And here, I would instead say this dot width is equal to width. That's what I'm passing in. And this dot length is equal to length. So again, I have two constructors, two ways I can call this. Now I'm going to test this, and I'm going to come back to the Java doc that I ignored to begin with, because I don't know how to do it. And I'm going to declare another rectangle and say R2. And I'll say R2 is equal to new rectangle. And I'm going to pass in 7, 8. Actually, I guess I need to declare it. Oh, I did up here. Never mind. I'll wake up here in a second. So that's creating another instance of R2. Makes sense on overloading? Doesn't matter. Like over here, I could have a third constructor. Where I could say int length and int width. And I know I can't spell. So then, say this dot so just a different way of putting it. Now there's three constructors. I could even pass Boolean in, Boolean length, Boolean width, and set it to 0, 1 type of deal. So you can pretty well do anything. Now, if I didn't put this int here and I passed in integers, it would still work, because an integer by default could be a double. A double can't be an integer, so it couldn't go the other way. That would blow up on me. I love objects when you start working on them because they're so cool what you can do with them. But anyway, Java doc. Let's go see how to do that. It says comment, so it's nothing real exciting, but you got to put the appropriate amount of like slashes or asterisks or whatever. Java doc example. And I never remember because I actually don't document that much. Documentation is slash asterisk 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 slash. Okay. I think it has to come right after your name. Um, oh no, here it is, Java Doc. Put after the class. I'm a cheat. Copy that. And now over here, now I go to my rectangle. And was it before the curly braces? After the curly braces. Okay, so I just put this in here. Okay, so let's do rectangle R3 equals new rectangle. Now right click on that and see show Java doc. And if this doesn't do it, I won't waste time on it. Cannot perform show Java doc. So how do you compile a Java doc? Now process the using Java doc utility as follows. Create missing Java doc for I did on that. I wanted on rectangle. Okay, let's try that again. Tools. Analyze Java doc. Okay, so create missing for set width. Okay, so I'll click fix selected. That's my set width. Okay, so now if I come up here, it probably put a template in for set width. That's weird. Did I not click fix it? Choose all of those and choose fix selected. I bet set the set was there. I just didn't look above it. But see how this rectangle now above it says this. This is a rectangle. Rectangle object. Only purpose. That's so if you're creating a library, and I don't create libraries, which is why I don't have this knowledge. But if you're creating libraries for other people to use, then you got rectangle In theory, the R4 is equal to new rectangle, like this. When you right click on it, you say show Java doc. I don't have one for that one. Which one did I put in? Two doubles, two integers, two integers. Nah, still doing something wrong. But it would show the documentation for it. So, I'd have to probably go watch a YouTube video to refresh my memory. Since I have no intention of creating objects for other people to use, I probably won't ever do it. Go watch that. Um, remember how we did, we had an import up here, import java.awt.point, like that. Point P1 equals new point. Okay, now, still won't show it. Maybe it's something's my configuration here, because I'm sure they have Java doc on their point. And if I navigate to the source, maybe the declaration. Maybe it won't let me do that. Navigate to the source. It's just not going to let me view the source on that. But you would see the Java documentation on that. And it doesn't look anything more exciting than what it put in there. You have to have a slash, two asterisks, and then a closing with this. And then these are your individual comments that go in the middle here. So. Aha, generate Java doc. I'll have to go watch that YouTube video after all. Not that I'll remember this tomorrow. I didn't fully expect it to do that much downloading. Since I've never worked with Java docs, it looks like it's downloading the code to accomplish the task. Okay. So now, in theory, if I come over here to rectangle, if I right click on that, show Java doc, that still doesn't do it. Oh well. Okay, I'm going to close that. I'm going to start a new example. Actually, I'll just leave it open. Someone steals something from it. I'm going to create a fraction. So I'm going to do a file, new project, fractions. Yeah, let's try it again. New project. Oh, that's my filter. Java Maven, Java application. fractions. Click finish. Now up here at fractions, I'm going to do a new Java class. Then I'll leave that as a new class. Paste in my main. There we go. That's going to be our main driver. That's what we'll call it. I need to create a fractions class over here. So I'm going to right click on that and I'll say new, and I'll call this a Java class, and I'll call it fractions or fraction. Click finish. Now our Java our Java class over here for fractions is where we're going to put like our numerator, denominator, and so forth. I won't put a bunch of gets and sets. I'll do it quick and dirty. Public, I'm going to assume I can just have integers in my numerators and denominators. So public int numerator, public int denominator. I'm going to have a constructor. So I have public fraction, and actually I'm gonna pass in a numerator and denominator, because really I don't want it to be blank, because that'd be 0 over 0, which wouldn't be meaningful. I do this dot numerator. This is going to refer to the variable or the attribute of the class. And then set equal to numerator, which is the parameter, the argument that I'm passing in right here. And I'll say this dot denominator is equal to denominator. Okay, so we just created a class fraction. Now over here, I'm going to create a new instance of it. So I'll say fraction f1. This is my main driver program. Is equal to new fraction 10 over 20. So that's 10 20ths. Maybe I want to have a print. So if I want to print a fraction, so I come over here, and I'm going to have a public string. I'm going to return a string and print fraction. And this may seem weird, but I'm not going to actually print it here. I'm just going to format it. So I'm going to return, and I don't know how this will work, so we'll see. I think I've changed it to a string. Yeah, I do have changed it to a string. So string dot value of this dot numerator plus, then I'll have a slash for my fraction, plus string dot value of this dot denominator. So now anytime I want to print a fraction, I just have to call this, and it'll print it in the correct, it'll return it in the correct form, and I can print it. Does that make sense in that? That's so here, after I've created my fraction, if I want to print it, I do f1 dot print fraction. Oh, by the way, there it finally popped up. If I come down here to Java fraction, this is where you should see your Java doc also. I just wasn't getting things to pop up in that last one. So that way you could read about what in the world is print fraction. David Hayes knew, but you know that doesn't necessarily mean anything. How about somebody else? How about David Hayes a year from now? Well, you know what that does. Now this is going to return a string, which means I need to set it equal to something, print it something. So system.out.print line. And again, your object should not contain print lines. You should not have one print line in your object for it to be done correctly. Now, if I run this, if I save it, now if I run it, and select main class, it should print 10/20. And there it is, 10/20. Now I'm going to write a simplify. So I want to simplify a fraction, reduce it down. So I'm going to come over to my fraction over here. Now, if I think about this, I can either reduce the fraction down that's in the instance I created, which means I destroy the original values, or I can set it up so it returns a fraction and then set it equal to another fraction. So those are choices you have to make. So I could say public fraction and simplify fraction and then fraction f. Do I need this here? Let me think about this. Okay. No, I don't need that. Because it'll be associated with a fraction, the instance I create. But that'll return a fraction. Okay, now if I had 10/20, the guideline on that is that we think of the largest number that divides into both of them. So I can do a backwards for loop to simplify this. Assuming I can remember it. INTX equals numerator. I'm going to start the numerator. I'm going to continue while x is greater than 1. And then I'm going to do an x minus minus. So I'm going to do a check if, and don't worry about this if you're not really into math. You don't need, I'm not going to ever have you do anything really heavy math-wise. The assignment on this is going to be to do a circle. Remember how we did the rectangle class? You got to do a circle, circumference and area. So not too challenging. And if you want to do more, fantastic. So here I'm going to check if the numerator is divisible by, I'm trying to think, I think that's percent in Java, is divisible by x, and, well, I should say that's equal to 0, and the denominator, percent x, that returns a remainder. That's also equal to 0. When it returns 0, that means it divides into it evenly. So the x divides into both those evenly. So if that's true, then I want to I'm going to need to return a fraction, so I need to declare a fraction. Fraction answer. I don't think I have to create an instance of that, but we'll see. So answer dot denominator or numerator is going to equal to numerator divided by x, and answer denominator is going to equal to denominator divided by x. Might not have been initialized. Okay. So answer equals new fraction 1, 1. And let me just make this clear, as you're seeing numerator all over the place. Okay, so this is starting with my numerator. Go down to 2. So it's brute force. So I'm going to go through and it's going to check each x value, going from my numerator down to 2, and see if it divides evenly into both the numerator and denominator. If it does, then I want to divide that numerator and denominator by x. Now, actually, after you hit your first one, you're done. Like if I had 10 over 20, it would start at 10, and 10 goes into 10, goes into 20 also. So it'd drop off. But I never put a break in there because I hate putting breaks in a for loop. Does that make halfway sense? Objects are the hardest things in programming, typically. So that's why I'm spending quite a bit of time on this. Now I'm going to do a return, and I'm going to return my answer. That's the fraction I just created. Okay, so if I come over here, I'm going to create a new fraction. And new fraction 1 over 1. And then here I'll say F2 is equal to F1 dot simplify fraction. So in theory, that'll go through and simplify my fraction and set it equal to F2. Now if I want to print out the value of that, I do system.out print line F2 dot print fraction. And why is the little yellow squiggly here? Sign value is never used. Okay. So if I run that, it should return 1/2 if it's working. Not even close. 5/10. What did I do wrong? Numerator. It did reduce it. Hmm. Okay, let's run this again. Then I'll do a debug project. Continue. So what's x equal to? X is equal to 10. So this should check to see if the numerator, which is 10, divided by 10 is equal to 0. My denominator, which is 20, divided by 10 is equal to 0. Okay, that's where I would expect it to be. This tells me my numerator is currently 1. Well, that would be. Okay, so this is 10. This is 10. 10 divided by 10 should give me 1, right? Okay, so this is 1 here. Denominator is 2, numerator is 1. That should give me 1/2. Oh, I see it. Yeah, bad coding. Not sure if I understand the answer. Oh yeah, no, I understand. Um, this numerator here, I should refer to answer and answer because I want it to, when I change this, I want it to refer to answer. So up here, where I do a new instance of it, I want us to go ahead and say answer. I wonder if this will work. Equals this. That should set the x or the numerator and denominator of the that instance to the answer theory. Okay, so let's run that and see if it reduces correctly now. Up in my object window. Yeah, somehow I've hidden my window here and I can't get back. That's nice. I'm gonna close NetBeans and go back into it. Well, there's my output window. Fractions. And it reduces 10 over 20 to 1 half. And I have no clue how to redock that. Oh well. Okay, now we got our simplified fraction. I could add fractions together. So let's take a look at that. I think I got time. Yeah. Although multiply fractions would be easier. Um, you have to think about how you want to design this. That's an important part on these. Like if I want to multiply two fractions together, well, maybe my goal is to do F2 is equal to F1 dot multiply fraction, and then I'll pass in like F2. The idea here would be that it'll take F1 times F2 and then return it. And you can return it F2 or F3 or whatever you want. I guess if I don't want F2 destroyed, then I need to create a new fraction. I might create a constructor that doesn't do anything but set the numerator and denominator to 1 instead of doing it each time. Okay, so multiply fractions. So I'm going to be passing in a fraction, and I'll be returning a fraction. Because that's what this is going to do, is return a fraction. So I come over here. Fraction, or public fraction. Multiply fractions. Now I'm going to be passing in a fraction. So I'll call it F. Now I'm going to have an answer. So I have fraction answer. Answer is equal to new fraction 1, 1. And the answer dot numerator. Remember fractions, you multiply two fractions together, you multiply tops together, your bottoms together, and simplify. So your answer of our numerator is equal to this dot numerator. This would be the instance that this is attached to, times the F numerator. That's the what we just passed in right here. And then our answer dot denominator is equal to this dot denominator times F dot denominator. Now I need to simplify that fraction. So I'm going to say that my answer is equal to answer dot simplify fraction. So I pass in answer to simplify fraction, simplify it, and then reduce it to, or return it to answer. And then I'll return answer. So now, there it goes. Okay. Now if I run that, both of them are 1/2, aren't they? 1/2 times 1/2 should give me 1/4. In theory, I guess I didn't print it though, did I? Helps to actually print out your results. System.out print line and F3 dot print fraction. Run it. I should see 1/4. And there's my 1/4. Now, as I'm developing this, I never have to, if I was doing mathematical programming, I'd never have to write code ever again, do fractions. It's done. I can use this for the next 20 years and call it good, if I put enough effort into it. Now, if I did add fractions, public fraction, add fractions, and I'll be passing in a fraction, I'll add it to the current instance. If you got 1/2 plus 1/3, what you do is you multiply. What you do is you don't have a 1 there. 5. There. You'd multiply the numerator. The numerator of the first fraction times the denominator of the second plus the denominator of the first times the numerator of the second, divided by, and then the 2 times 3. So that's the way to do a fraction. So I need fraction answer. Answer equals new fraction, 1, 1. And my answer of my numerator is equal to 5. F dot numerator times this dot denominator plus this dot numerator times F dot denominator. And my answer dot denominator is equal to my two denominators multiplied together. So F denominator times this denominator. And then I need to simplify the fraction. So answer is equal to answer dot simplify fraction. Denominator. So then over here, if I have F4, fraction F4 is equal to new fraction 1, 1. And I'll say F4 is equal to F1 dot add fractions. And I'll be passing in F2. And then system dot out dot print line F4 dot print fraction. Okay, so I'll run it now. It should give me 1 over 1, which isn't the correct way to display it. But we'll go with that. Or it could blow up. Uncompilable source code missing return. It bothers me. I screwed this up where it's not. Uh-oh. I don't have time to reboot or restart. Return answer. I didn't have a return there. Where did my output go? There it is. 1 over 1. Proper way to display that, if it's 1 over 1, would be just return 1. So I could change. I probably have time to change it. My print. Here, say if this dot numerator equals 1 and this dot denominator is equal to 1, then I'm going to return 1. Else, return that. So now if I run that, if it's 1 over 1, it'll return 1. Is this halfway making sense? Yeah, it's kind of heavy when you get into the fractions like this if you've never worked with it before. But what I'm trying to demonstrate on this is the power behind it. As I keep building this, and I did the add fractions or multiply fractions, Did I really have to do much in terms of simplifying? No, because the code was already designed. So I could use the existing methods and objects. Well, we'll go ahead and stop there. So I gotta go over and give a final or a midterm.